Hi, welcome to clickmyproject.com. Now I'm going to explain a complete demo of my project. Title is Protecting Location Privacy in Sensor Networks Against a Global Eavesdropper. In this project, I'm going to protect the source and sync locations privacy in wireless sensor network, which is major issues in wireless sensor network. Suppose the failure to protect such information can completely subvert the intended purpose of sensor network application. So we can preserve the location privacy for both sync and source in the presence of global eavesdroppers. The global eavesdroppers in the sense who has a complete view of the network traffic. In our existing system, they can protect only the source location's privacy. They can protect the source location's privacy by the flooding technique. But in the global eavesdroppers can easily find out the source locations by the path flooding. So in our proposed systems, we use the periodic collection and source simulation technique to protect the source location's privacy. Likewise, for sync location's privacy, we use the sync simulation and backbone flooding technique. Now I am going to explain a complete flow of my projects. For this project, at first I am going to create a sensor node in a network. After creating a sensor node, we need to provide the locations privacy for sensor nodes. Location privacy for sensor node in this form of source and sync locations privacy. Sometimes we can act as a source locations and some sync location as a data collector. For sync locations privacy, we can periodically send a dummy packet, and each node in the network can maintain a queue, and also using the key distributions protocol for sharing the data. And then we can create a multiple candidate trace, and then they simulate a source. Likewise, a sync locations privacy, at first we can create a fake sync in this sensor network. After creating the fake sync, we can send the real event. Now the fake sync also receives the real event message. And then we can identify the backbone members. After identifying the backbone members, send a message to all the backbone members in our network. Now I am going to demonstrate the complete source of my package. At first I am going to run a home file. In home page I am going to create a network formations. Now this is a network. In our network we have a 5 sensor node and 1 data collector. After creating a network, we are going to start the server. Now the server will be started. After starting the servers, we need to create each node identity. That means we can select a node name, and the node ID will be generated for that selected node, and the public key and private key for our selected node, and it will be kept in our database. Likewise, the node B, the node ID will be generated, and the public key and private key, and we can be stored. Likewise, the node C, node D, node E, and sync. After providing the node identities, we need to click forward. In this frame, first you need to select which locations privacy. It means source or sync locations privacy. First I am going to protect the source locations privacy. In source locations privacy, there are two techniques will be there. One is a periodic collection and another one is a source simulations. At first I am selecting the periodic collections and click action. Using periodic collections method, we can protect the source locations privacy. For this, you need to click a network. In my network, we have a 5 node and 1 data collector, and start a sensing. Now the node C will be sends the real event and find the path. That means we can send the real event message to the sync through which path. Now the possible ways are assigned. After assigning the possible path, we need to enter the starting node. That means we can enter the node C, and the destination node is sync. then we need to click a source. Now we can transfer the data into the way of 245. So I am choosing a 4 as my path, and so we can send it directly to the sync. So using this way we can send a real event message to sync. After finding the neighbor nodes, we need to click forward. In this frame we can create a key distributions. That means a key exchange, key sharing, key pairing generations will be worked. At first I am selecting the source node and the next hook node. Likewise the pairwise key will be generated. Now I can encrypt my sensed data using these pairwise key generation. So unauthorized persons, that means adversaries, cannot break this information. For this key pre-distribution we use the Diffie-Hellman algorithm. Likewise we can generate the pairwise key for all the node in a network. After sharing the key, we need to click forward. Now the sensor node C will be act as a source node, and I am going to enter the neighbor node. That means I can forward the data to the node D. After selecting the neighbor node, we need to click a sensed event. Now I am going to select the sensed event file. Now our sensed files will be ready to send. Before sending our data, we need to ciphering the data. The ciphering can be performed based on the key pairing. Now our sensed data will be ciphered and will be sent to the neighbor node. And then we go to the node D and run. At first we can enter their neighbor node. Neighbor node is sync, and click the queue details. Now the node C can forward the data to the node D. So we can you have a one real event. So we need to click receive the real event message. At first the data received in encrypted form, and then the message will be forward to sync. So we go and run a sync file. In a sync node, we need to click a receive button. Now the data will be received from source. It will be in an encrypted form, and we need to decrypt it. Receipt file will be decrypted. Now the sync node will have a data. The source node will be a C. It will be transmitted through the D, and the data is. After performing the periodic collection method, we need to protect the source location's privacy using the source simulation. For this, we go for this page and select the source simulation and take an action. In source simulation page, at first we need to click a network. This is our network and will be a start sensing. Now the sensor starts the real event. Now the node B will be sense the real event and simulate the source. Now the node B is the real source event, and we can simulate the source. The node D and node A is also our source nodes, and we need to find the path. Now the starting node is B, so 2, and the destination node is sync, and we can find out the neighbor node. So we can forward this to 4R5. If I am choosing a 5 as a neighbor node, it can reach our destination. So I can take a path 2, 5 and 6. So I can transmit the data through this way. After finding the neighbor nodes or path, we need to click a forward. Now we can enter the neighbor node name, that means the node E. After entering the neighbor node, we need to sense a real event. So here I am choosing the sensed data and click open. Now the sensed file will be ready to send to the neighbor node. Before sending the data, we need to ciphering it. So now here in the source simulations, the real and fake event can be forwarded to the neighbor node. So now go and run the node E. In the node E, we need to enter this neighbor node, that means sync, and then click receive. Now the data will be in encrypted form and it will be forwarded to the sync. Now go and run a sync. Sync, at first we need to click receive. Now the sensed data can be received from source. It is in encrypted form, so we need to decrypt it. After decrypting, you can sync can identify which node will be act as the source node for this round, and source node can be transmitted via this path. The content will be, and we need to find out the performances between the periodic collection and the source simulation. For click performance, and this will show the if you want to know the periodic collections performances result, in the sense the privacy and energy can be estimated by using the periodic collections method and source simulation method for calculating the energy and privacy level. You can click a view to view the both privacy and source simulations level. Now using the periodic collection, the privacy level can be and the energy consumption is. So likewise the source simulation techniques privacy level and energy consumption. This will be the performances graph between the periodic collection and the source collection. So red color denotes as the privacy level and blue denotes as the communication range. That means the energy consumptions. After performing the source simulations, we need to protect the sync locations privacy. For protecting the sync locations privacy, we go for this page and select the sync locations privacy backbone floating technique and click action. For protecting the sync locations privacy, we use the sync simulation and backbone creations method. At first we can create a network. After creating the network, we need to simulate a sync. Now the sync will be simulated. Then click next. After simulating the sync, we need to identify the neighbor node list of each node in a network. At first I am going to choose a node 1 and find the neighbor node list. That means neighbor node information. After finding the 1, we like to find the 2's neighbor node list. Likewise, we can calculate the neighbor node for each nodes in a network. At last, final node. After finding the neighbor node informations, we go for sensor node A and click a backbone creation request. Now the neighbor node details can be sent and we waiting for the election response. Likewise, you go and run a node B. In node B also you need to click a backbone creations. Likewise, node C. In a node C, we can also create a backbone creations. Now our neighbor node details can be sent and we can waiting for election response. And likewise, go and run node D. In a node D, we need to click a backbone creations button. At first, it will send the data and then you're waiting for the election response result. Likewise, node E. Likewise, node E, we need to click a backbone creations button. At first, it will send the data and then the election response. After sending all the election response messages to nodes, we need to run a backbone. In the backbone creations, we need to select a node name. After selecting the node, we need to count the coverage area and coverage area node and then add this member to the list. Likewise, the second node and get the count and get the coverage node. It has no contain the coverage node. Likewise, the node 3 and the coverage node details and add to member. After the members can be added, we need to send the selected message to all the nodes in a network. Now it will be broadcasting the selected message. Now first after broadcasting the election message, we go for each node and receive the response. At first, I am going to the node 1. Here the election message will be received and click the status. It will be selected for backbone members. So likewise, go and receive the second node election message and its status is not selected for backbone members. Likewise, the node C, it will be selected. Likewise, the node D, it's not selected. Likewise, node E, it's also not selected. After identifying the node status. Here we go for this frame and select the backbone members. At first we need to identify the member list. After identifying the member list, we can select the source node. Now I am selecting the node C as a source node, and the sync nearby node is node D, and you can forward the data via the selected path. Now node C is a source node, we can forward the data to the sync via the node D. After selecting the source node and identifying the path, we go to the source node. Here the node C as a source node, and here we enter the neighbor node. This is a node D as our source neighbor node. And after identifying this neighbor node, we need to send a sensitive event to the neighbor node D. Here we can select the sensitive data. Now our sensitive file will be ready to send. Before sending, we need to cipher it. Now this will be forward to the neighbor node. So we go on to the node D and click the neighbors node and click receive. At first the data can be received in an encrypted form, and it will be forwarded to the sync. Then go to the sync . Sync node, we first click a receive. Now the data can be received from source. It is in an encrypted form, so we need to decrypt it. So now the received file will be decrypted. Thank you for watching this video.